Assalamu alaikum guys, welcome back to a brand new video. So in today's video our main topic is what is DSA and why we need to learn DSA. So this will it will be not going to our coding tutorial. It will be just a simple quick info like what is DSA and why you need to learn DSA. So let's continue our video. Alright, so I am into my whiteboard. So here first of all let's take a quick overview what we are going to learn. We are going to learn what is DSA. Just give me a second. Okay, we are going to learn what is DSA and one more thing also, ignore my writing. I know my writing is not good, so just be cooperate with this. I am just going to select bangers with 80 and not this one. This font is not looking good. Let's change it with now this one is also. Okay, so we are going to learn what is DSA and why we need to learn this and which programming language required for learning DSA. So let's take our first point. Basically DSA is not about one specific language, programming language. You can learn DSA with any programming language. You can learn it with Python, you can learn it with Java, you can also learn it with C, C++. Like it's not program language dependent, it's independent DSA. Like you can learn it with any of the language, but we mostly recommend to use C++ or Java for learning DSA. It's because we need to write raw code in DSA. So that's why we prefer Java or C++ for learning DSA instead of Python. So this is our first point, like DSA is programming language independent. So you can learn it with any programming language. So let's move on to the next step. So the mostly asked question is like normally students ask like why we need to learn DSA. So this is the our going to our main question, why we need to learn DSA. So I'm going to explain you everything with an example. So instead of giving you lecture with theory, I prefer to you explain you with an example. So that's why in this tutorial we are going to use a example how we can use DSA in real world programming. Like as you guys know, DSA is basically DSA stand for data structures and algorithms. Like you can see we have three words. First one will our DSA. I'm going to change its color with red. Okay, so first of all we have D. D basically stand for our data. So this will be our data. After that we have S. So basically S stand for our structures, which is basically STRU. See, this will be our structure. And at last we have the word A, which is basically stand for algorithms. Basically the algorithms we are going to type, this will be our A. So the combination of our data, structures and algorithms is known as a DSA. So DSA is a basically short type of data structures algorithm. So DSA is the name of some basic techniques and algorithms which we follow in our program for making our program more efficient, more scalable, and make its executable speed more fast. So you can think DSA is the one of thing which can help to serve our website, or you can set serve your code 100x more faster. For example, if you write any algorithm in simple for example, if you write any program, let's suppose this is your program. So normally this program take almost 10 seconds for execution, like it is taking 10-second execution. And this is normal traditional programming, like you normally make write if else conditions and make some algorithms, and normally it takes 10 seconds for execution. But DSA is one of thing, if you proper follow DSA and write proper algorithms for your code. For example, if you apply DSA, like this is your normal program, but if you cover it with DSA, mean you apply some DSA logics here, like writing some efficient logic, it helps to serve your code 10x more faster. Like for suppose it is taking 10 seconds, but after writing proper DSA techniques, it will be take only 1 to 2 seconds for execution. Like instead of 10 seconds, it's just taking 1 or 2 seconds for execution. So this is the benefit of applying DSA into your normal program. There is one more thing, like if you are learning DSA, you must know how to use flowcharts, and you must have at least basic grips how flowcharts will be work. And if you are not familiar how flowcharts will be work, I'm just going to give you a quick overview. But if you guys want a full complete tutorial on how flowcharts will be work, just shoot a comment. I will definitely make a complete detailed video on flowcharts. Alright, so these are the shape which we use in our flowchart. So like first of all, there is oval which we use for the start and stop. After that we have a parallelogram which we will be used for input and output. After that we have a rectangular which will be our processing shape, and after that we have a diamond shape which will be used for conditioning, like if else condition. And after that we have an arrow which we will be used for flow direction of our program. So these are the basic shapes which we use in flowchart, and I am assuming that you must know how this flowchart will be work. So let's take a problem and apply some DSA techniques on it. I will explain you, like first of all we will be take an query like any problem, and we are going to follow up the 3 steps. So let's continue our video, like our main part of our video. So before continuing the video, I'm going to tell you the curriculum of our video. I will explain you, like in this video I will explain you how DSA can be work and how DSA is beneficial for your program, and I will explain you all these things with examples. So in this video we are going to take 3 examples and understand these examples one by one. And for this example we will be understand, first of all we will be taking example like any query. So we will be try to solve this question with our flowchart, and after that we will write some pseudocoding for our program. After that we will be in our program, like the question which we are going to take, I am going to apply some DSA techniques on it, like how DSA basically works. So it will be help, these problems will be help you to why DSA is beneficial. So let's take our first problem and start our proper video. So as you can see, we draw something like this. This is the thing we draw now, but let's move on to the next part. So this is the flowchart for our third problem, which we basically our problem is take an input and tell us is this number is prime number or not a prime number. So it was our problem. So here I created flowchart for this, but before understanding this flowchart I want to explain how basically our input is working, like which formula we apply here, or you can say which logic we apply here. So first of all I'm going to explain you this. So it's a simple thing. First of all it is going to take an input For example, user type input equal to 5. So prime numbers are those numbers which are only divided by their own value. For example, the number which is divisible of 1 and the divisible of its original value. So these are the prime number. For example, this is 5 and this 5 can only be divided on 1, like it can be only divided in 1, and after that it is not completely dividing on 2, it is not completely dividing into 3, because if we divide 5 into 3, 3 1 are 3, then remainder will be 2, and same thing if I follow with 2, 2 2s are 4 and remainder will be 1. So it is not completely dividing on this number, and it also not completely dividing on 4. So, and it's only divided on 5, like if I type 5 and 5 divide 1 and then a remainder will be 1, so it's mean it is the remainder will be 0, so it's mean it totally divisible on its original value 5 and 1. So that's why 5 is a prime number. So this is the our logic for finding like which number is prime number or not a prime number. So same that in prime number 1 is not included because every number is divisible of 1. So overall you can say this 5 is only divided by its own value and give remainder 0. It's mean this is a prime number. So same step you can follow. For example, if I take another example, I have a number 6. Now let's see actually when what happen, like when we type a number, and the logic or you can say the formula for finding prime number is simple. Like I will explain you, just give me a second. Okay, the formula for finding prime number is quite easy. Like first of all, we need to take a number. For example, I take a 7. Then what we do, we are going to manually divide the numbers between 1 to this value, like all the numbers between 1 to this value, and we are going to divide it with all these numbers, and if any number is completely divisible of it, then it's mean it's not a prime number. But if it is only divisible on its own value, then it's mean it's a prime number. For example, this is 7, so it's mean we are going to test it for finding out is it prime number or not. What we are going to do, we will start from 2 because 1 is dividable with all numbers, so 1 is not included. So we will be divided with 2, 3, 4, 5, 6, and 7 is also not included because this is original value and we know it is divisible of 7. So we are going to test this number with these 5 digits, and if these 5 digits are completely divisible of this, then it will be not prime number. But if these digits are not divisible of it, then it will be a prime number. So if we try with 2, and we know 2 is not completely divisible of 7, like if 2 3s are 6, still 1 is remainder, so it's mean it will not work. Same thing will happen with 3. If we type 3 2s are 6, then still 1 is remainder, so it's mean this is also true. False. If I try this with 4, and it is same, 4 1s are 4 and 3 will be remainder, so it is not divisible of 4. If we divide with 5 and 5 1s are 5, still we have remainder of 2, it's mean it is not completely divisible of 5. Same thing if I try with 6, it will be say 6 1s are 6 and remainder will be 1, so it's mean it is not completely divisible of 6. It's mean it is not dividing on these numbers, so it's mean 7 is a prime number because we can simply divide it with 7. 7 1s are 7 and remainder will be 0, so 7 is a prime number. So this is the logic we are going to follow for finding our prime number. So same thing are going to done there. Like for example, we have 6 and we will be try. So as you know we need to start from 2, 3, 4, 5 and 6 because 1 is not included, and see this 6 is also not included. We will be test this with 4 digits, 2 3 4 and 5. So when we divide 2 with 6, 2 3s are 6 and remainder mean r equal to 0. It's mean 6 is completely divisible of 2, so it's mean 6 is divisible of 2, it's not a prime number. So in output it simply return 6 is not a prime number, because 6 is completely divisible of 2. So at start it give us like 6 is your completely divisible of 2, so it means it's not a prime number. So we don't need to check these with all remaining numbers like 3 4 5. It's divisible of 2. So it means this is our formula, or you can say logic, for finding the prime number. Same thing I am going to apply here. Like the flow chart I made, the same algorithm, like the same logics I explain you, same logics are follow up there. But these are basic level, because as you guys know, we are learning about DSA. So this logic is simple, and after explaining this, we will be move next on applying DSA on this problem. So I will explain you with more. I will explain you in more better way. So just wait. So first of all, let's understand our flowchart. So as you can see, first it's programming start, and after that it is taking a number. So number will be user input, like user can be type here 5 6 7 8, like any value user can type. Like I'm going to use this, for example, user will be type here 7. So the input of user will be 7, or it will be 1 2 3 4 5 6 7 8 9, any you can say it will be any number. So after that we are assigning a variable which is c equal to 2. Actually this is our starting value, as you guys know. I clearly mentioned here. Here you can see we are dividing values from 2 to the user input value, because 1 is not included here. So same thing I do this, I'll declare a variable which is started from 2, because 1 is not included. After that what is going to do, it is going to check our condition c smaller than num, like the number user type. If this number is smaller than c, then it will be simply return output prime. So like it's a prime number, it will be simply return, because c we stored 2 in our c, so it means c equal to 2. As I mentioned here, c equal to 2. So if the number user type, like user type 7, so their condition there will be 7, so it will be checked 2 smaller than 7. So no, 2 is not smaller than 7, so it means this condition is false. So when this condition will be false, it will be run this no block. So when this no block will be run, then this logic will be executed. But we will be going later. First explain, if user, for example, let's suppose if user type in number 1, like if user type 1, so it means the user input is 1. So here we declare as a variable c equal to 2. Here when it will be check condition, c is smaller than num. So in c we store 2, and our new num with user type is 1. So it means 2 smaller than 1. Yes, condition will be true. And then condition will be true, it simply return output prime, like 1 is a prime number, and it will be exit the code. Like in the case if user type value which is smaller than 2. Let's suppose if user type number 2 here, like you in input user type 2, and as we know 2 user type input number 2, and here it we declare variable c equal to 2. After that when it will be checked, like 2 is stored in c, and same thing 2 is smaller than 2, then it will be checked this, and in this case our condition will be become false, because 2 is not smaller than 2, 2 is equal to 2. So when we write 2 smaller than 2, then this no block will be executed, like this condition will be false, and then this no block will be run, and then our remaining logic, like the logic we write here, it will be called out. So this is the our sorting or finding method for prime number. So let's explain it a little bit more deeper. So let's suppose let's take an actual value. First I was explaining you with 1 and 2 only. So let's take any actual value. So before taking let me erase this stuff. Okay, just give me a second. Alright, that's good. And also guys, make sure you guys subscribe my channel, and thank you. Okay, so first of all, in input we will be take a number which is 7. So here already we declared variables equal to 2. So when this will be checked, 2 smaller than 7, no, condition will be false. And when condition will be false, this no the condition will be false, then this condition will be call out, because you can see our errors are pointing toward this. So when this will be call out, it will be checked this n percentage c equal to 0. So what is n percentage c? Percentage is basically, you can say, modulo. You can say modulo. In, if you know programming language, it will be modulo. It will be give the remainder of your value. As we mentioned here, num percentage c. It's mean number will be agar actual value. For example, I have a number 7, so it will be actual value. Then it will be divide, and in with c. So in c we store a variable which is 2. So in here it will be type 2. So you can see 2 7. So it will be checked. 2 3s are 6, and its remainder will be 1. So you can see it modulo sign, like this percentage sign is basically modulo sign. It will be check the remainder value. Like if we divide number with this c variable and the remainder will be 0, if remainder equal to 0, then it will be simply return prime number. Sorry, I think I missed one thing here. Like in shapes, just give me a second. Like if this condition will be true, then it will not directly exit. First it tell it will be print it's a prime number. I think I forgot to add here. Just give me a second. Sorry for this. Delete. All right. So sorry for this in conversation. No, it will be written if they will divide a number with c, and if its remainder will be equal to 0, its mean it's completely divisible, then it will be simply written not a prime number. So you can see in our case, when we divide 7 with 2 equal to 2 3s are 6, our remainder will be 1. So it's mean this condition is not true. So when this condition is not true, then this no block will be executed, like this no block will be executed. So when we call this then it will be moved toward this program. Then here we mention c equal to c plus 1. So it's mean our c variable equal to, in c we store 2, so it will be take 2 plus 1, and our c will be become 3. So now we will store 3 like c equal to 3. So again it will be you can see after that it will be call out on this condition, and here it will be again check condition c smaller than num. So this time the value 3 is stored in our c variable. So it will be checked 3 smaller than 7. No. Again condition become false, then again condition become false. It will be again execute this block. So when this block will be execute, it will be again call num percentage c. So it's mean number is 7, and in c this time we store 3 in our c value variable. So it will be checked 3 2s are 6, and remainder will be 1. Still this is not completely divisible, so its main condition again become false. Then it will be again execute c equal to c plus 1. So when this will be call out, this time with the value of c is 3, but when it will be to c equal to c plus 1, it will be c will become 4. So when it will be become 4, it will be check out this, and again it will check 4 smaller than num. No, it will be again execute, and when it will be again execute, it will be again divide 4 with 7, because this time our c become 4. So it will check 4 1s are 4, still the remainder is 3. It is not completely divisible. It will be again call out, then c equal to c plus 1, which will be become 5. So same thing like, and 5 divisible, 7 5 1s are fun, still our remainder will be 2. Like here 5 and 5 1s are fun, remainder will be 2, still it's not completely divisible, it will be not give prime. And when 5 plus 1 it becomes 6, so it will be divided 6 smaller than num, and it will be checked with no. So it will be again check c smaller than 7, 6 1s are 6, and it will be return 1, still it's not. And when it become c equal to 7, like 6 plus 1 equal to 7, so when it will be go and check here c 7 smaller than 7, because we stored this time our C value becomes 7. I hope you guys understand what I'm trying to explain. Like this time the value stored in C is equal to 7 and our actual number is also 7. So it will be check 7 smaller than 7. Then it will be return. I think we misspell one thing here. Sorry again. Actually, we are going to type C smaller than equal to now. Like this time when the C become 7, then it will be check is C smaller than or equal to 7. So it will be check like in C we have stored 7, so it will be also smaller than equal to num, so it will be also 7. So 7 is equal to 7. This means condition become true. Or when this condition become true, it will be simply called yes, this will be output. So this time this condition will become true, and when this condition become true, it will be called out this, the output is prime, and exit our code. Basically it is not exit. In here we need to type and, basically start and end. So I mistakenly type exit, but this is basically our end. Start and this is end. So our code will be end. So you can see check out, it manually check all these value between 2, it start from 2 and take until our user input. Like as you can see we type 7, so first it take 2, then it will be divided with 3, then it divided with 4, then it divided with 5, then 6, and then 7. So this type our logic is calling out. So I hope you guys clear how our algorithm is running and how flowchart is also working. So let me show you one more step, like one more advancement in this problem. So first of all I'm going to erase everything. Just give me a second. And I know my writing is not good and my English is also not good, so please just ignore both of things, because English is not my native language, so that's why my English is little bit weak. Okay, so let's take another example. For example, this time user will be type the number 6, like number equal to 6, and here it will be check C equal to 2, and here again C smaller than num, like 2 smaller than num. Alright, so now you can see it will be check C smaller than num. It will be say no, because we C equal to 2 and number equal to 7, and 2 smaller than 6 is equal to false. So it will be execute this. When this will be execute, it will be take a number, so our number will be 6, and it will be divisible on 2, because at a time C equal to 2, so it will be divided to 3 are 6, a remainder equal to 0, and you can see we got 0 remainder. So when we got 0 remainder, this condition become true, because num percentage C, like number module C equal to 0. Yes, its remainder, basically the remainder value is equal to 0. So it means 6 is completely divisible of 2. So when this condition will become true, so it will be simply run this yes command, because if a condition become false, then this block will be called out. But then this time our condition become true, so when our condition become true, it simply call out this not prime number. Basically it will be called this number is not prime number, and it will be exit our codes, like it's only check for once and it completely divisible, so it will be simply print the number is not a prime number. So this is the logic. So let's make some advancement in this logic. So for this, first of all I'm going to explain you something like which type of advancement you can made in this code. So let me take one example for you guys. So here, just give me a second. For example, let's make the angles of, so let's take the divisible value of 36. Okay, so let's for example, let's take a value of 36, like I have this number which is 36. Okay, and let's write it's all the numbers which are multiply of 36. So for this, for example, I am going to say here I know this block is not calling out, just give me a second. 36. Okay, we have 36. Let's take it some values. For example, first of all, I want to take all the angle like multiple angles of 36. So first I'm going to do 1 multiply 36 equal to 36. After that I am going to try with 2, like 2 multiply by 18 equal to 36. After that if we take with 3, like 3 multiply by 12, like 3 multiply by 12 equal to 36. After that we will be go with 4, and 4 multiply by 9 equal to 36. After that we are going to take 5, but as you know, 5 is not visible, like 5 is not basically factor of 36. We are taking all the factors, so 5 is not. After that we will go with 6, and obviously 6 multiply by 6 equal to 36. After that we are going with 7, but 7 is also not factor of okay, just let me arrange it for you guys. Okay, 7 is also not factor of 36. So after that we will go with 8, and 8 is also not factor of 36. After that 9, yes, 9 multiply by 4 equal to 36. After that we will be go with 10. 10 is not factor. 11 not. 12, yes, 12 multiply 3 equal to 36. After that 13. 13 is not factor. 14. 14 is not factor. 15 not. 16 not. 17 no. 18, yes, 18, like 18 multiply by 2 equal to 36. After that 19 no. 20 no. 21, 22, 23, 4, 5, 26, 27, 28, 9, 30, no. So at last 31, 32. Okay, so at last our remaining value is equal to 36 multiplied by 1 equal to 36. So you can see these are the factors of our value, which is 36. Let's suppose, so these are the upper factor. Okay, but if you guys notice one thing, we are repeating some values here. Like what I mean to say, we are repeating values here. For example, if I check it with just give me a second. Okay, if I check with 1 multiply by 36 equal to 36, like if I check with this, then is I need to again recheck it with this, like 36 multiplied by 1 equal to 36, like is I need to check it with here? No, because if I check this one, then why I need to check this? I am just increasing by steps, nothing else. And let's suppose if I check with 2 multiplied by 18, which is equal to 36. But if I am checking with this, then I need to check it with 18 multiplied by 2. Like is I need to check it with it? No, because if I am checking this one, then why I am again going to repeating my this step here? So this is our DSA. Why are you repeating your steps? If you have your own logic, then why are you repeating these steps again and again if you already test them? So as you can see, when we find all our factors here, if you can follow, you can see we find all our factors. This is the thing, like 1 multiply 3 and this step. These steps are simply repeating. Like here we have 1 multiplied by 36, here we have 36 multiplied by 1, here we have 2 multiplied by 18, then 18 multiplied by 2, here we have 3 multiplied 12, here we have 12 multiplied 3, here we have 4 multiplied 9, and here we have 9 multiplied 4. So this is common, like 6 multiplied 6, except this, these are the same steps are repeating. So if these steps are repeating, then why we need to check with these steps? We can simply follow up these 4 steps, these are enough. Like if you want to factors or want to apply logic, so then instead of checking with all these 1 2 3 4 5 6 7 8 9, instead of checking with all 9 values, if you can simply check with these 5 values, it will be give you same result. Then why we are applying some 4 extra like these four extra logics here, like you can say programming lines or anything you can say, like why we are repeating them? It is not necessary, because we will be get our output in 5 steps. So same thing is known as DSA, the techniques which we follow up onto our logic, uh, and because normally coder use dry method, DRY, dry mean don't repeat yourself. Like if you already write something, then don't repeat it. Same thing, if we already write there, then why are we repeating this? No, this same logic I am going to explain you up here. Sorry, we not need any template. Okay, so same thing I'm going to apply here. Like what I mean to say, what I am applying here, let me explain you. And if you know, as you guys know, for checking, for example, if you want the prime number of 12, what we are going to do, we are our logic is manually dividing it with 2, like 2 to 11, like 2 3 4 5 6 7 8 9 10 11, like our logic is one by one dividing with all these values between this from 2 to between this, and it is excluded, it is not included. So it will be checking from 2 to 11 all the values between them, and checking one by one is our logic is like is our number is divisible of 0 or not, and it is its prime number or not. Like it is checking manually with all these steps. But why we are repeating our steps again and again? No, we don't need to repeat this. If instead of this I am going to apply square root on it, like a simple thing, for example, if let's suppose you want to let me explain you a little bit more clear. I think you might not understand why what I do here, so just let me explain you a little bit more advanced way. So you can see, for example, we have a number. Here I'm going to type a number, this number. I don't know this number is prime number or not a prime number. I don't know, seriously. But let's suppose, or you can let imagine this is a prime number. Let imagine. I'm not sure it is prime number or not, but let imagine. So our this logic will be, what is our logic going to do? Like this logic, this this is very boring step, switching our cursors again and again. I don't know why they don't have any shortcut key for this. Okay, so you can see if our code is like this number will be executed in this algorithm, what it will be going to do? It will be going to repeating these steps, like checking from 2 to until this number. Like as I mentioned here, it will be start from 2 to 2. This number is not included, but the minus version of like 9 5 9 8 9 4 8 4 6 5 4 5, like it will be take from these to these steps. Like it will be going to take these steps for going to take all these, follow all these steps, like execute our logic this time, the number of time, then it will be find is it prime number or not prime number. As I can say, like in simple words you can say minus 2. So basically this one is also okay. Why is it so bad? Okay, so if you minus by 2, then the remaining about will be our steps. This logic will be going to execute our logic this time, and then it will be find is our number is prime number or not. As I say, I'm not sure is it prime number or not, but let's suppose this is a prime number. Let's suppose, just suppose it, this is prime number. So it will be going to like 1 2 3 4 5 6. It is basically 95 lakh million. I don't know which value, how to pronounce it. Let me make it little bit easier. I'm going to type 9 5 1 2 3 4 5 6. Okay, you can also join. Okay, so this will be value. So it is basically our 9.5 million. Basically it's our 9.5 million. So it will be going to test it until 9.5 million times. Like you can simply minus 2, then will be 9512975 will be remaining. This time it will be test, and then it will be say is your number is prime number or not a prime number. So these are the huge step. If you know 99.5 million, it's so big amount. Like for testing all the 9.5 million steps manually, it will be take a lot of time. For example, it may take 5 seconds. For example, it will be take 6 seconds, maybe it will be take 10 seconds. It will be totally depend on your programming language. If you know, if you test with C++, it will be fast, but if you test with Python is a quite slow, so it will, maybe it will be take more time. So it's mean it's totally depend on time is totally depend on your programming language, which you programming language choose. But why so much steps? So here DSAs come. Like DSA will be say, hey brother, why you are worrying? I'll help you. Like DSA will help you to this sorted amount of our you can say DSA will help you to you can say DSA will help you to removing the number of steps. Like instead of following like executing our code 9.5 million times, it will be give us some easy steps. Like DSA will do this. However, who it can be do in our logic, and it's totally depend on your logic, like which type of logic you write. Then we need to apply DSA techniques, logics algorithm according to it. So in this tutorial, I'm not going to explain you like which algorithms you need to learn, like mean your deep learning, heap learning, or you can say recursion concepts. I'm not going to explain all this stuff. I'm just introducing you with DSA, how DSA works. So let me see, as we check out here, like we are just repeating steps, like 1 multiplied by 36, 36 multiplied by 1, 2 multiplied by 18, 18 multiplied by 2. So why we are repeating step? Same thing I'm going to apply here. Like we will be write to logic. Why he is repeating these steps? Like might be possible sometime it repeats same steps. Like if it will be check 2 multiply by 951, then at a time like I can explain you. For example, if it will be testing with 2, then why it need to test with anything else? Like in simple words, I am going to repeat removing some repeating steps, like this type of repeating steps here. So for this you can simply take under root, square root, like for this logic, for making it sort, because as you can see here, it is just square root values of this. So if we apply here c square root 2, it will be sort our lot of problems. Like instead of this I'm just going to type here c square root of the 2, just to make sure you square root of 2. So no, it will be only check the condition with square roots. So this is quite easy, and trust me, it will remove a lot of your steps. I am going to explain you this flowchart again with a little bit more example. Like still I add square root, and I am telling you it will be remove almost your 50%, or you can say it will be remove 70%, or it may be remove 20%. Like it will be optimize your code, but which percent, it's totally depend on the user input value. So I'm going to explain you this concept, but just give me a second. We will be take it very clearly. Or if you don't want to use square root, then you can use c multiplied by c. This will be also same. Like we have in math, we have 100 of steps to solve a problem. So here I'm going to explain you a little bit. Like each time it is taking, as you can see, it is taking 9.5 million. But if we apply square root here, like this time we apply square root. So when we will be apply square root, then instead of following 9.5 million step, it will be sort our code. And how much step our code will be sort, I will show you. just give me this. I'm just going to copy, and I want to find the square root of this. For this I'm going to open a calculator. Calculator. Okay, all right. So here we have calculator, and here if I write steps, I want square root. So I'm just going to type square root this and equal. So this is our value 9753. So this is our actual value. Like here I'm going to type, where is basically this. I am going to make it little bit 9753 only. Like you can say that instead of 9.5 million steps, it will be give us result only in 9753 steps. Like your number is prime number or not. So you can say how much optimized is our code. Like first, I'm sure you guys understand me what I want to explain. Like first, it's taking 9.5 million steps for finding is our number is prime number or not a prime number. But when we apply square root, it will be give us result in 9753 steps in only. You can see how much optimized code. One side is 9.5 million, and second side we have only 9k, basically 9000 steps. So here this is the beneficial. You can see how optimized is our code. This is DSA, because DSA is not the name of single square root or simple. It is combination of lot of things. The thing I'm explaining you about DSA, this is 0.01% of DSA only, but I'm pretty sure this example will be helps you a lot. What is DSA? How much DSA can optimize our code? And you can clearly see first it was checking our code in 9.5 million steps, which are huge. But no, after applying square root, it will be give us same result in only 9000 steps. So you can see, for example, if you are in Python, because I am also Java and Python developer, so I normally when I write my logics, I can see clear difference between the speed of Java and Python. Python is little bit slower and it is acceptable. Like according to one example, Python take almost 40 seconds to count 1 billion records, like count 1 billion, and C++ take only 3 to 4 seconds for counting 1 billion. So you can see how much difference. One side is 3 to 4 seconds and one side is 40 seconds. So you can understand how much C++ is faster than Python. So this is totally depend on your programming language. Like if you are writing this logic in Python, then might be possible it will be little bit slower, but if you are in C++, it will be a little bit faster. So it's totally dependent on your programming language. But let's suppose the 9.5 million steps are taking around about 20 seconds for executing, like 20 seconds. But when we add square root, it make our code optimized, and now it is taking only 9,000 steps. So it's mean if 9.5 million take 20 seconds, then these 9,000 steps only take 1 to 2 seconds. So you can see how much optimizes our code. In first behalf, it is taking 20 seconds for giving us output, but in second term, when we add square root, is just giving us result in 1 second. So you can see how much optimizes our code. So this is DSA. Simple. Same logics you can apply in multiple things. Like I'm not just saying it will be only with square root or anything else, but this is the minor example how DSA works and how much it will be optimize your code. And remember, you can apply DSA techniques, logics, algorithm on any programming, any tech stack. Like no matter if you are doing web development or app development, game development, nothing matters. You can apply it anywhere. So this is the optimization of our code, and I hope so you guys clear how optimized is our code. Like instead of taking 9.5 million, it will be count our logic in 20 seconds. So let me go into more depth of this. So for example, let's take a small value. I know this is too long. Let's take 7. So what we do, we add square root of 7. So if I want to check this square root of 7, but normally if you want to find the prime number of 7, like how much step we are going to follow, we are trying with, we will start to 3, 4, 5 and 6, mean total 5 steps. It's taking 5 number and it is doing, first it will divide with 2, then it divide with 3, then 4, then 5, then 6. Mean overall it's taking 5 steps for finding is it prime number or not. But if we apply square root on it, like as we mentioned here, if we apply 7 square root, so after applying 7 square root, let's see first of all what its value in calculator. I want the square root of 7, which is 2. So after adding 2, it will be only give us result in 2 steps. Like instead of following these 5 steps, like first it giving us result in 5 steps, but no, it will be give us result in only 2 steps, just because adding square root. And trust me, this method is so efficient. Like you can't say okay, this method will be not workable, might be it's risky. No, it's 100% genuine and tested. It will give efficient result. So you can see first it's taking 5 steps, and no, it will be do our problem in solve our problems in 2 steps only. So this is the efficiency of program. Same thing, for example, if we have number like 12, sorry, not 12, let's take 13, because 12, for example, let's take 12. I want to explain you with it as well also. So if you know 12 is already optimized, like by default it is 12, but when we try from 2 to 11, but like 2, 3, 4, but when it start from 2 to 6 or 12, it's completely divisible. So it take only one step for telling is it optimized or not optimized. Simple. So it's not a quite long challenge, and don't worry, it will be only. So this square root will also work, you know, in it. Like I'll explain you a little bit more deeper of this. Like after just couple of minutes, instead of using square roots here, like in my algorithm I directly put square root, but you can't put directly put square root here, because in programming language we have a lot of things. Directly if you put square, it will be give us float number. Then comparison of an integer with float number is not quite easy. So I have these, I know about all this problem, so I'll try to solve this in different way. Like this method is like the different method we are going to use is same as square root, but it is little bit easier for us. So don't worry, I'm just going to moving toward it. I'm doing it soon. So just for explaining you guys, same thing if you are taking any other number. For example, if you are taking 17, so first thing we need to find, like normally it will be take 15 steps, like it will be take 15 steps. It's lagging, just give me a second. Normally if you want this find prime of 17, it will be take 15 steps. These are this is huge amount of steps. Like from 2 to 16, if you count, this will become 15 steps. But after applying square root here, you can simply check out square root of 17, it is 4. So it's mean after applying square root, it will be give us result only in 4 steps. Like instead of 15 steps, it's giving us result only in 4 steps. So you can say how much optimized and efficient is our code. Almost you can say 80 to 90% our code is efficient now. Like 80 to 90% speed is increased. So this is the power of DSA. So you can make more advancement in this. Like for example, as you can see, we write a logic here for prime number. There is lot of complex logic, say lead code problems and other things, I know, but this is just simple example for you. So let's write a flow chart of our you can say our algorithm, but this time this code is not efficient, as we know, because it is taking so much time. Like if I remove the square root from this, or now you can see this code is too slow, as we determine here from these examples. Okay, normally it's taking lot of steps which are so boring and headache. So let's write an optimized code. So for making this optimized, I'm not using square root, as you know, here I explain you with square root. But instead of adding square root here directly, like instead of adding square root like this, you can also follow one more step. This step is if you don't want to add square root, and I'm not preferring square root. Actually, this thing I'll explain you here. These are just examples, like for your better understanding why square roots, how it's work. So for your better understanding, it's not compulsory to use square root in this chart, because we only every time when we write logic, we try to write efficient code. So for making it efficient, like if I directly write square root na, it will not work. Then what I will need to do, if I want the square root will be directly work, first of all I need to convert this number into square root. Then might be possible it will be give us in point value, which is decimal numbers, like you can see float values. So then I need to use type conversion, like converting these float values into value, and when this float value will be converted into an integer, then we need to make a comparison here, like we need to add some more steps here. So instead of adding more steps and making our code complex, I want to write my code more easy way. So instead of adding square root, instead of this I will simply use c multiply by c smaller than equal to n, like number. Instead of this square root, I am just going to do multiply this c multiply by c. This is also same like square root, but a little bit easy way, like then we don't need to repeating steps. This will be also work same as square root, but it's just a little bit easy method. I hope and I'm assuming if you guys are watching this video, you must have basic programming languages like how if else condition works, and what are loops, heaps, memories, programming languages, difference between programming languages, type of programming languages. I hope you guys have basic grip on it, but it's all okay. So let me test this flowchart, but I'm going to write a new flowchart for this, so for the guy explaining you guys in better way. So just give me a second, I'll back after writing a new flowchart here. Alright, so this is our new flowchart. I just copy paste the old, just change this condition, and as I told you, I'm not going to use square root here. I want to write code simple. So the example I explain you below, the same thing will be happen for this. Don't worry, it will be also the same steps, just writing different way, because when I add this, it will be not giving us error after adding this logic. I don't need to add type conversion here, like converting into float, blah blah blah, these boring steps. So that's why I just simply add this here. So it's quite easy, don't worry. I'll explain you why you are worrying. So here let's again take a number. For example, we have number, just give, where is my pencil? Okay, here. So this time let's take a number 7. So again it is variable declares equal to, but this time when it call it here, the condition is little bit different. C multiply by c, it is basically multiply sign, static sign, you guys know. C multiply by c smaller than equal to num. If yes, then this will be run. If no, then this will be run. So this time our c equal to 2. So when this logic will be called c multiply c, it's basically mean 2 multiply by 2. So our c will become 4. So it will check 4 smaller than or equal to 7. So condition is no, because 4 is not 7 or not equal. So it's mean condition become false. When condition will become false, then this block will be called out. So it will be again check number with c. As you guys know, we see this thing above earlier. So it will be again check like number 7 is divisible of 4. It will be say 4 ones are 4, remainder is 3. It's not divisible, condition become true. So when condition become false, it will be go here. So here it can be check out, like first there is 2, then it become 3, it will become 3 plus 1, which will be become 4. So it will check here 4 multiplied by 14 equal to 16. He said 16 smaller than num. He will be like yes, condition become false. Like 16, like you can see it become 4, and when it come here 4 multiply by 4, which is equal to 16, so it means 16 smaller than or equal to 7. So its condition become true. 16 is not like condition is become true, like jo 16 hai, it's not. So it will be take like you can say okay guys, just give me a second. Okay, so it will be check like 16 multiplied by 16 smaller than 7. So it will be say no, it's not. So it will be check out with this, it's not also. So then it will be simply print it's a prime number. So these are the steps, like you can say कि it's our code is going to follow, and explaining you how everything is work, and is your output is prime number or not a prime number. So this is the for this video. So as you can also try out samples like with 7, 6, 9, 2, 5, X, Y, Z. Like you can try any steps which you wanna want. Alright guys, so thank you for this video. I think this video already become too long. So if you guys think this video is interesting or helpful, please do a like and subscribe my YouTube channel. And thank you for watching. Let's meet in next video. Okay, bye. Allah Hafiz.